Fine. Here BGP lab, I'm taking here two routers, 1 and 2, will enable the directly connected interfaces through neighborship. So in between, I'll take 16.1.1.1 for this IP, interface IP, and for this IP, 16.1.1.2/24, and I'm taking a AS number. Will configure in between eBGP because packet tracer won't support iBGP. So that is the reason I am taking here eBGP. So AS number is here will take 100 and here will take AS number is different one, that is 200, and we'll take some loopback IP addresses like LAN interfaces. We'll take some loopback interfaces. Loopback interfaces, that is loopback is 1. The IP address is like here, router 5. So 5.5.5.5, and here loopback is 1. The IP address is, this router is 6. So we'll take 6.6, and this is a router R5, and this router is R6. So now move to the configuration part. Enable config terminal. And one more important thing is, I'll explain in lab. In one router, only one ASL will be work. Only one AS. We can enable at one router only one AS number. If you are using two AS number, it won't work. But in eIGRP, if you are using eIGRP, two AS also it will be work. Two AS also will work, because EGP is for the IGP protocol and this is for the exterior gateway protocol, EGP protocol. Don't confuse it. Here at one router only one AS will be support. I'll show you that in lab. Interface fast Ethernet 0x0. IP address is here 16.1.1.1 and subnet mask 255.255.255.0 and no shutdown. First we'll make a reachability in between two routers. Now enable config terminal interface fast Ethernet 0x0 and IP address is here 16.1.1.2 and 255.255.255.0 subnet mask and no shutdown, and exit from here. Just ping reachability, check the ping 16.1.1.1 reachability is there or not. Oh, so we have a reachability, and we'll create one loopback interface. config t host name R6 and loopback interface loopback 1 and IP address is the 6.6.6.6 and subnet mask 255.255.255.0 and exit from here. No shutdown not required. And here also exit interface loopback 1 and by default it is changed to up by default. It is logical interface, logical IP address, logical interface. Loopback does it mean? IP address 5.5.5.5 and 255.255.255.0 and no shutdown not required. Exit from here. So as I mentioned here, the BGP having direct neighborship and indirect neighborship. Indirect neighborship. Direct neighborship is with the help of directly connected interfaces. Indirect neighborship is logical interfaces. What we created? Logical interfaces. That is a logical interface neighborship. That is indirect neighborship. And direct neighborship is directly connected interfaces. Two types of neighborship we can establish in BGP. Directly connected and indirectly connected. If you configuring the indirectly neighborship, the reachability is required. The reachability is required. In between, the reachability is not there, then indirect neighborship is not formed. Make sure. So we'll connect here direct neighborship only. We are doing small lab. So before that, host name is here R5. And make sure use write command. After then, now move to the configuring the eAGRP BGP neighborship. Before that, if you have any queries,
Sir, exactly why we use loopback?
yeah, loopback IP address is actually it is a logical interface. So as I mentioned here, indirect neighborship. So we can establish what is the requirement of loopback. Loopback interface always up. We cannot shut down it. If physical interfaces are down also, loopback interfaces are up. If we have connected likewise, you enabled with the help of loopback IP address neighborship form, indirect neighborship, the above interface goes down also, below interface is up. So with the help of indirect neighborship in BGP, the best thing is like if the neighborship is not went down, it will be not went down. It in dynamic now dynamic routing protocols, if we connected likewise, the neighborship in between, this is the dynamic neighborship. Dynamic neighborship OSPF. How it will be established? Directly connected interfaces. Directly connected interfaces. This is and this is. But here in BGP, with the help of indirect neighborship, with the help of loopback IP addresses, this is the logical interface. Always the interface is up. So here you can assume show IP interface brief. So here we have the fast Ethernet 0 by 0. So fast Ethernet 0 by 1. Sorry. This is the loopback IP address. It is always up only. You can check here. So in real time, we'll use with the help of indirect neighborship only because the interfaces won't goes down. But physically, if some damage is there, cable cut is there, then neighborship will goes down, dynamic neighborship. But BGP not down. BGP not down because we connected with the help of loopback IP addresses. So that is the reason we need for loopback IP addresses. Got it?
Yes, sir. Like,
Fine.
how will the other system know about this loopback? Like,
Will advertise the
advertise.
prefix in
Okay.
with the help.
Okay.
Will advertise or they knows when we configure the loopback IP addresses, then neighborship
Okay.
will advertise the prefixes to with the help of network command. With the help of
Okay.
network command, it will be available.
It's kind of predefined.
Yeah, predefined.
Okay.
Not predefined loopback IP addresses. Whichever you require, you can configure it.
Okay.
Whichever you require, you can configure it. Fine. So we are starting to configuration of our BGP. So just use router BGP. Here you can give the question mark. So yesterday we discussed eIGRP and OSPF and RIP protocol in last classes. Now BGP, border gateway protocol. So BGP, give the AS number here, autonomous system number. So which I mentioned here, 100 here. So now coming to protocol, you can check earlier. So IP protocols, just one command, I enable the BGP protocol. So here you can check it is IGP synchronization. Leave it that we have a two AD values, internal and external. We have not advertised any prefixes. Maximum path is only one. Here, maximum path is only one. In production network, just use this command. Show IP protocols. Entire protocol will be available. It will be shown. In production network, use this command. Config T and router BGP. Yesterday, I have used 100, right? And try to give different one. Now 200. So BGP is already running with AS number. So one router will take only one AS. Only one router will take only one AS. It won't take different AS. We cannot assign multiple AS at one router. Only one router, one AS number. So now establish the neighbor in between two routers with the help of neighbor command. Neighbor use then IP address of neighbor address 116 dot give. If you want to enable the with the help of loopback IP address, give the loopback IP address. If you want to enable the physical IP address, then physical IP address, directly connected and indirectly connected. So 1.1.2 and give the question mark here. What it is asking, remote AS. Remote AS is my remote AS is what is 200. 200 is my remote AS. See, as I mentioned here, 200, but I have given the 100. But you can verify it. Cisco Packet Tracer does not support internal iBGP. iBGP not support this version. This version is not support iBGP. Only external. Only external neighbors are supported. So I want to show you this thing. That is the reason I have given. So 200. Understood? The Cisco Packet Tracer is not support iBGP. Only support eBGP. Now you give with neighbor command. Neighbor 16.1. This is I am giving about this router here. Now move to this router. That much only. Neighbor 16.1.1.2 and remote AS 200. Here no need to advertise the prefix. If you want advertise the prefixes, then network will advertise the prefixes of 5.5.5. Network 5.5.5.5 and sorry 0. And I am advertising the entire prefix. So that is the reason. Give the question mark and mask. Here write the mask. mask. Here not taken the wildcard mask. Earlier we discussed OSPF, eGRP. They will take the mask IP address. Here you should have to mention mask, subnet mask 255.255.255.0 and give the question mark. Anything else? Nothing. I have advertised the prefix also. This prefix. Now move to this router. Router BGP 200 of this and neighbor is 16.1.1.1 and my remote AS is 100 and adjacency is formed. It is a fast protocol. Convergence is very fast. In BGP, convergence is fast. Established the neighborship, you can check. Adjacency is formed. It means with this router and network 6.6.6.6 0 and mask is 255.255.255.0 and exit and write the command. Now we'll verify the entire thing and exit from here, write command. Show running configuration pipe section BGP. What I have used here commands, only these commands, two commands. Router BGP and neighbor command and network command. Here you can verify. And same thing.
Here in network command, can we use like 16.1.1.0?
No, not required.
Not
If you want to
required.
advertise, if you
Okay.
want to advertise, use that command. And
Okay.
already the BGP is established in between. If you want, you can use that command also.
Okay.
Okay, we'll do that also. Pipe section BGP. This is a R2 configuration. By automatically those things is enabled. And here this is R2 configuration and R1 configuration. And now move to the verify the BGP routing table with this command. Show IP BGP. With this command, we'll verify the BGP routing table. If you have any queries, ask me. Sorry guys, I am on mute. I hope no one have any questions. So this is a BGP table. With this command, we'll verify it. What does it mean? Here we have a. I'm audible, right? Guys, I'm audible.
Yes.
So here, best prefix and valid prefixes. Star and greater than, it's showing here best and valid prefixes. These are the best and valid prefixes. And it's a next hop from where it is getting. R1 is getting from 16.1.1.2. With this, from here we are getting with this next interface, next hop IP address. If valid and best is there, then only we can reach that prefixes. The BGP routing table and show IP BGP and give the summary here. Summary, with the help of summary, will find out the neighbor status. Status will find out. So here the status, if it is active, then it will be showing here. Here prefixes advertised here 4 it is showing means the established status is finished. The established status is finished. Just down here, write command and config T interface fast Ethernet and 0/0 shutdown. Now use here the same thing. Neighborship is down. It will be take 3 minutes, 180 seconds. The neighborship is sending the messages. So IP BGP neighbor. Still it is showing here. The neighbor is hold down timer here showing. Last wait, write and last read. These are timers. You can check here. It will be wait up to 180 seconds. Then only the neighborship will be down. Still the neighborship is alive. Even though interface is down. Even though interface is down, still neighborship is down. So we'll wait. And BGP router identify. With this, it is a 5.5.5. This is the router ID of this router. It's a router ID. And where we'll find out this? So IP BGP neighbor. Can check here. BGP neighbor is 16.1.1.1 directly connected interface and remote AES is 200. It is external link. It is an external link in between and BGP version here using 4 and remote router ID is 6.6.6.6. I haven't mentioned, but it is elected by default because of yesterday we discussed how it will be elected. First one is we should have to manually we have to enable the router ID. Otherwise, whichever the loopbacks interface is there, that will be elected as a loopback interface. That is router ID. That is router ID. It will be elected router ID. That is router ID. It will be elected. If we haven't enabled the router ID or loopback interface, then whichever the physical interface is there, highest physical interface, it will be elected. That is router ID. And BGP states is active now. So you can check here. Status is active. Here status is active because neighborship is down. Up to it will be sent milliseconds of 7 second 39 milliseconds. Earlier we thing changed this. and route refresh advertise received. It is IPv4 unicast they are sending, and here we have the open message, notification message, update message, one received and one sent, open message one sent and one received, only one prefix we advertised here. Keep alive messages every 60 second it will be sent, every 60 second it will be sent. And we'll check now. Still active state, can verify from here. And neighborship status, show IP BGP neighbor. 3 minutes is not finished, right? Here it is, it should how to show something ideal or active state. Physically interface is down, even though it is not showing. 3 minutes finished, I think so. Hey, status, how not changed? Show IP BGP neighbor. Active. People every 60 second it is sending. We'll check the routing table. Show IP BGP. Still it is showing. So only one prefix is showing. That is originated itself. Now another prefix is not showing here. Earlier it was shown 6.6.6.6. Now it is not showing here because neighborship is down. Show IP BGP summary. Show IP BGP summary. BGP summary. Keep alive, it is showing. Why it is showing? But leave it. The packet tracer issue, I think so. Now what we'll do? We'll turn it on. We'll verify something here. Different other things. Interface, fast Ethernet, 0 by 0, and no shutdown. Use no shutdown command. Now check. Show IP BGP. We'll verify the routing table. Show IP route. Here we have it's directly connected routes. Show IP BGP summary and show IP. The neighborship now formed in between. Now you can check with this command, adjacencies form in between. Now check show IP route. Earlier we have not get this route 5.5.5, only we got 6. Or locally whichever the prefixes are available, those only we got. But now you can check here, we got the IP address of 5.5.5. We whichever we originated, that we are getting with the help of AD value, that is 20. Here you can verify, and here metric is not showing 0 because directly connected, and from where it is getting via this interface 16.1.1.1. If you want to check particular BGP routing protocol, routing table, show IP route BGP. With this command will verify the BGP routing table. This is the prefix we are getting. and R5 is originating 5.5.5.0 and through AD value is 20. It means it is a eBGP neighborship in between form. In between eBGP neighborship is formed via 16.1.1.1 through we are getting through directly connected interface we are getting. Guys, understood the routing table? If you have any questions, ask me. Otherwise, we'll redistribute from BGP to eIGRP. Redistribution. We'll do the redistribution from OSPF to BGP and BGP to OSPF. We'll redistribute these things. Guys, if you have any questions, redistribute information from another routing protocols. We'll redistribute now. OSPF to BGP and redistribute BGP to OSPF. Screen is visible.
Yes, sir.
Yes, sir.
Okay. Five dot 1.1.1 for this and 15.1.1.6. This is a ASBR router. This is a ASBR router, autonomous system boundary router. Now I'm configuring it and we'll take here AS number is in this AS number is 100 by 2, 200 by 2, and now we took here we'll take here AS number 300. AS number autonomous system number is 300. Enable config terminal interface fast Ethernet 1 by 0. IP address is 15.1.1.1 and 255.255.255.0. Use no shutdown command and exit from here, and we'll configure for this interface also. Router 5, exit, and interface fast Ethernet 0 by 1. IP address is here 15.1.1.2 and 255.255.255.0 and no shutdown. We'll use no shutdown command and exit from here, and now move to the directly connected. Before that, we'll ping test. We'll do the ping, because if ping is not happen, next nothing will work. Reachability is required. Yes, we can reach to this interface, directly connected interfaces. Now write command, use write command, save it, and config terminal will enable the BGP now router BGP 100. So it's 100 only, and use neighbor command. Neighbor 15.1.1.5 and use remote AS is 300. This is a 300 of a remote AS. Here we are using remote AS is 300. And this remote AS is once will enable here 100. And exit from here. Move to this router. And router BGP, this is 300. And use neighbor command 15.1.1.2 and remote AS is 100. Yes, BGP neighborship is established in between two routers. You can verify it. Show IP BGP. This is a BGP table. Yes, we are getting the path is 100 and 200. 200 is this neighbor and 100 is this neighbor. Two paths we are getting through added and best paths. We advertised, and we'll advertise one more prefix also. Here we'll create loopback here 4.4.4 and we'll advertise that prefix also. Interface config t interface loopback 1 and IP address 4.4.4.4 and subnet mask 255.255.255.0 and exit host name is R4. Do write and router BGP 300 network 4.4.4.0 250 mask. Here use mask. How will advertise? With the help of mask 255.255.255.0 and just and write. How will advertise the prefixes? I hope everyone got it with this command. %10 is there. No issue. Now verify from this router we are getting the prefix or not. So IP BGP. Yes, we are getting the three prefixes whichever we advertised. This is getting from 300 and 100. And you can verify this and show IP route with this command global routing table 4, 5 and 6. 3 loopback IP addresses we are getting. This is a B means BGP. B means BGP here. And now redistribute it. And we are getting the prefixes only for BGP, whichever the BGP is there, those we are getting. So IP, BGP. Here we are not getting from OSPF prefixes. OSPF, this is the OSPF routing protocol. We are not getting these prefixes. Now we'll check this router. Show IP, BGP, we are getting, and global routing, show IP route. See, here we are getting the entire prefixes. We have to get these prefixes in this router. I will not configure here OSPF, even though I need this all the prefixes. OSPF, so IP route OSPF. This entire prefixes I need from this router. So from this is my LAN prefixes and advertise this from different location. You can assume likewise. So how we'll configure it? How we'll do this? Just simple use redistribution commands. Config T. First move to the which process ID we enabled here, which router. Before that, we'll exit and show IP protocols. We'll use here. Two protocols are working. One is BGP protocol is working. One is OSPF protocol is working. Two protocols are working here. Two protocols are working here. So show I wait. We check the routing table also. Now we'll configure it. Redistribution. How we are redistribution? Just keep in mind. See here. Important thing. Config T. If you have any queries, ask me. Router OSPF 100. First, enter in OSPF configuration. Enter in OSPF configuration. Give the question mark here. Check here. Redistribution option is there. Yes, we have the redistribution command. Redistribute information from another routing protocols. Another routing protocols. So use redistribution. Which protocol you need? I need BGP protocol now. Use BGP here. And which AS number? AS number we are using here 300. Just that much only. Metric or metric type, subnet, leave it. Those things, leave it. No, not required for. If only class full network will be redistribution because of BGP, it is a by default enabled in auto summary. So by default, enable auto summary means here we no auto summary. So it won't carry the with summarized prefixes. Summarized prefixes. So no worry about this. And exit from here and now move to the BGP configuration now. Router BGP 300 and redistribute. Here give the OSPF which process 100 of this process. No, metric is not required. Match prefixes. If you want to match only particular prefixes, then you can just enable here. Match prefixes not required here. Now check here in this routing protocol. Earlier only we got these prefixes. Now check from here. Yes, now we are getting entire the prefixes. Question mark is means IGP protocol. This is the IGP protocol question mark. And from where we are getting from 100 and 200. Likewise, we will redistribute the prefixes. You can check from here also. This now tell me this router we call it as a ASBR router. This router is a ASBR router, autonomous system boundary router. This router is ASBR router and this router is ABR. Autonomous. This is the ABR router. This is the ASBR router. Boundary router, autonomous boundary router, autonomous system boundary router. This is a concept. How we enable. You can check here also. Sorry. Border router. You can check here which one is a border router with this command. Which one is the border router with this command we can enable. Show IP OSPF here the border router ABR. This one is the border router 3.3.3.3. Can check here. Here we'll get the entire database table to IP OSPF database. So summary, this is a summary net. It means we are getting here. Enable to IP OSPF database. This router will originate the whichever the prefixes are we are getting from another routings, it will be originate. So here you can verify the entire thing. So IP route, we are getting the entire information. 192.168.10.0, this prefix through BGP we are getting, and this prefix we are getting, and this prefix we are getting, entire thing we are getting. This is verified. How we did redistribution. This is the redistribution command. With the help of we configured it. Guys, any doubts? Just verify. Earlier we have not get the entire routing table BGP, only 4 prefixes we got. But now you can check here. Now you can check here. Entire prefixes we are getting. When once we redistributed entire thing. If you have any questions, till we verified everything. If you have any questions, ask me. I'll stop the recording.